Congratulations, you are officially in the last outcome of this unit, and it is only one lesson long. So how pumped are you to be done with quadratic functions? This is lesson 4.7, solving problems with quadratic functions. This relates to R5 in our outcomes. So this outcome is all about word problems. So you've already been dealing with word problems in every sort of lesson that we've been doing leading up to this. So now it's just a matter of being able to take it from each individual scenario already preset by the lesson to just being given a word problem, identify how this is a quadratic equation, how this can make a quadratic function. So the key things to do is 1, set up your variables, 2, set up the function, 3, complete the square, and 4, find the vertex. So example 1 has Seth is 50 meters, has 50 meters of fencing to enclose a rectangular area. I always like to draw pictures for these. I'm a very visual person, so that's what I'm going to be doing. When we talk about 50 meters of fencing, that means we're going around the shape, which means I'm talking about my perimeter is 50 meters. Find the maximum area that can be enclosed. What are the dimensions? So we can call it length and width to describe our rectangle, and we can write one equation that says 2 lengths and 2 widths will equal my perimeter. So instead of P, I can actually fill that in with 50 meters. Alternately, I can write an equation for area saying it's length times width. But right now, that doesn't help me because there's absolutely no numbers in here. Moving forward, what I can do is I can manipulate my first equation so that I can substitute it in for the second equation and solve for a maximum to answer the question of what is the maximum area that can be enclosed. So I'm going to isolate length. So it's 2 lengths is 50 meters minus 2 widths. And so 1 length, everything's going to be divided by 2. When you divide by 2, you can either leave it as a fraction, but that might be a little ugly when we go to substitute it in here, or each term, not just one, but both need to be divided by 2. So 50 divided by 2 is 25. 2 divided by 2 is 1. So 25 minus a width is going to give us our length. And that kind of makes sense because if this whole rectangle is 50, then if we cut it in half, that should be 25, 1 length and 1 width. So now I'm going to substitute this equation in for L. So instead of length times width, I'm going to have 25 minus width multiplied by the width again. From here, I can distribute this. So my area would be equal to negative W squared plus 25W, and we need to complete the square to find my vertex. And so that's going to be negative W squared minus 25W. Half of 25 is going to be 12.5, and then we are going to square that. 12.5 squared is going to be 156.25. So we've technically subtracted that because the negative was factored out in front here. So that means that I'm going to add 156.25 out on the outside. And so my area is going to be W minus 12.5 squared plus 156.25. So you might be looking at this equation and being like 156.25, like that's a huge number, and like how can I have a negative value for my dimensions? And you've got all these red flags going off, but you need to step back and take some perspective. Remember that this is my y value of my vertex. The y, or the output of this equation, is my area, not my length or my width. Also remember that the x value of my vertex is not negative 12.5, but it's positive 12.5. We always switch the sign, which means that my maximum area is my y value of my vertex, so that's going to be 156.25 meters squared. My width is going to be 12.5, and that means that my length I'm going to have to solve for by plugging back into this equation here. So 25 minus 12.5 is going to be 12.5, so that works out nicely. And don't forget your units on both of those. And so that is my final answer for this question. So let's try another example. Two numbers have a sum of 20. So m plus n equals 20. Again, sum means adding. Does the sum of their squares have a minimum or maximum? Determine the minimum or maximum and the numbers. So that means the sum of their squares, so that's m squared plus n squared equals sum total. We can use any letter for this. I'm going to use P. So again, I've got a quadratic equation, but I have too many variables. I can have two variables for representing kind of like the x and the y, the independent and dependent, but I cannot have three. So I'm going to isolate again out of that first equation and plug it into the second. So I'm going to isolate m and say that m is actually 20 minus n. From here, I can substitute this equation in for m because they are one and the same. That's what the equals implies. So now I've got 20 minus n squared plus n squared equals my maximum minimum sum value. From here, again, I'm going to be squaring. Now, remember, when you square a binomial, the definition of squaring is that it's multiplied by itself, which means it's actually 20 minus n times 20 minus n plus n squared. So I've got 400, and I don't really need these brackets once I've completed with squaring this. Negative 20n, and negative 20n is negative 40n, and then plus n squared plus n squared. So all in all, I have 2n squared minus 40n plus 400. From here, because I'm wanting to talk about maximum or minimum, I am actually going to need to complete the square to determine the maximum or minimum. I can already see from the equation, though, based on the fact that my a value is positive, that this is going to be opening upward, which means that my value is going to be a minimum. So I can already state that I'm going to have a minimum. It's just a minimum of where. So first things first, factor out 2n squared minus 20n. Remember that we've taken the 2 out of both of these terms. Then we've got plus 400 over here equals p. Well, half of 20 is negative 10. Squared is 100. So it's really like we've added 200. So we're going to subtract 200 as well. So we've got 2 n minus 10 squared plus 200 equals p. Again, when we talk about minimum and maximum, we always look at the y value because that's vertical. And so we're looking at the 200 there. And that is for my sum. Okay, but that's my sum, is my minimum, is 200. I need to actually figure out the numbers. So n at that point would be positive 10. And again, remember that's because we switched the signs. And that means that m is also going to be 10. An apple orchard has 20 trees per acre. So you might want to start just like jotting down facts on this one because it looks like there's some units to consider. 20 trees per acre. The average yield is 300 apples per tree. It is estimated that for every additional tree per acre, so we're adding trees, the yield per tree is reduced by 10 apples. Minus 10 apples. How many trees per acre will yield the largest amount of apples? So we've got kind of two scenarios to set up. We've got the number of trees is going to be, and we can decide however many of this, so per acre it's going to be 20 plus t, and that's going to represent how many trees are added. Then I'm going to try and also figure out how many apples per tree. So that's kind of like my yield. So I'm going to use y, and that's going to be 300 minus 10 times t. Okay, so we look at these equations, we're like, great! So I've got t in both of them. I'm all set up, but number one, these don't look like quadratics because I don't have a square on either of my t values in either equation. And the question is actually asking, I want the largest amount of apples total for the whole thing. Right now, this is my yield per acre, or per tree rather. I want to know my yield for the whole thing. So if we look at our units, we've got trees per acre and apples per tree. If we wanted to figure out apples for the whole acre, I'm going to have to figure out by multiplying the trees per acre times the apples per tree. And if I set it up kind of like this, as if it looks like a ratio, I can see that my trees are going to go away and I'm going to end up with apples per acre, which is what I want. So I need to multiply these two statements. So A is trees per acre, Y is apples per tree, and so my total number of apples, I'm going to use M just for maximum, is going to be 20 plus t times 300 minus 10t. From here, I'm going to use FOIL to expand this. So I've got 6,000 and then minus 200t plus 300t and then subtract 10t squared. So I'm just going to rearrange this while I collect like terms. So I've got negative 10t squared plus 100t plus 6,000. So now I've got a quadratic. Let's complete the square, find my maximum. Because again, that's what we are looking for, the largest amount. Largest amount means maximum. That also fits with what we have for our equation, so that's kind of validating what we've done so far without completing the question. This negative a value means my parabola is going to open downward. That means that I have a maximum. From here, we complete the square, factor out 10t squared minus 10t plus 6,000. So half of 10 is 5, squared is 25, but really I've subtracted 250, so I'm going to add 250, which means that my final vertex form of this equation is going to be negative 10 times t minus 5 squared plus 6,250. So how many trees per acre will yield this? So T was just my additional trees. So T is going to be 5. So trees per acre means I'm going to have to plug it back into that. So it's going to be 20 plus 5 equals 25 trees per acre. That's my final answer. So I'm not done here. Always go back to the question once you've completed the square and ask yourself, what am I actually supposed to be getting out of this equation? So we've got example 4, and then you'll be able to do your work on your questions and do some practice so that you're ready for the assessment. The goal is that you should be ready for this assessment tomorrow. So a parking pass costs $20. At this price, 150 students will purchase passes. So if I go C is the cost of my pass, then it's going to be $20 to start with. And then N will be my number of students, and it's going to be 150. For every $5 increase, so adding $5 some number of times, 20 fewer students are going to actually buy passes. What price will maximize profit? So again, C is that price or cost. Okay. Profit is when we multiply how much each individual piece costs by how many people buy it. So the total money made. That's what profit is. So for A, I'm going to take C times profit is going to be C times N. So it's going to be 20 plus 5N multiplied by 150 minus 20N. Given this, I'm going to multiply out, use FOIL. So I've got, this would be 30, add 2 zeros, and then we've got minus 400N plus 5 times 15 is going to be 750N, and then subtract 100N squared. Again, you are more than welcome to use a calculator for this. How I kind of use mental math here is every time we have a 0 tacked on the end, we just tack it on the end of our final product. So 2 times 2 is 4, and then 2 zeros. That's how I get 400. When I did this, I did 2 times 15 is 30, and then added my 2 zeros on. And same thing works for 5 times 15. Well, I think about 15s in terms of time, just because that helps me kind of imagine what we're talking about. So 4 15s is 60, because 15 after is like a quarter of an hour. So 60 plus another 15 gets me that 75, tack on the 0. So that's kind of how I approach these mental math-wise. Again, I'm getting some validation here. If I rewrite this, I'm wanting to maximize my profit, which means I should have a maximum. So my parabola should be opening downwards. If I rearrange this into descending order in terms of my degree of my variable, I get negative 100 is my A value, so it is opening downward. This is going to be 350 again, and then add 3,000. I'm going to factor out 100. Leave me with n squared, and it's also I'm factoring out a negative, so that changes the sign in here. And that's going to leave me with 3.5n plus 3,000 out here. So from there, half of 3.5 is going to be 1.75, and 1.75 squared is 3.0625. So when I finish my completing of the square, I've got negative 100 n minus 1.75 squared. Oh, and then don't forget that because we've added this, but it's really subtracting because of out here, we're going to also add 306.25 on the outside. So that's why I kept my decimals, because I'm dealing with dollar values, so I can go to 2 decimal places. Always keep your decimals until the end of the question. It'll ensure that you are being the most accurate that you can be. So instead of just 3,000, we're dealing with $3,306.25. So I've got this all finished out. A is asking what is the maximum profit. So remember that this is equal to P. So my profit, my maximum output is my Y value of my vertex. So max profit is going to be that $3,306.25. Now, this seems weird because we are looking at whole values up in here. So this is not a legitimate answer. As much as it matches my equation, my maximum profit would actually be, and we're dealing with multiples of 5, so it's not even going to just be like knock off the decimal. It has to be $3,305. So when you do these questions, always go back and make sure your answer makes sense, because we cannot sell part of a parking pass. Okay, so that's why this happens. Now, I'd want to double check that this is an okay value to have. So what I'm going to do is I'm going to plug that in over here. So I'm going to check my answer to make sure it's legitimate. Okay, so by checking my answer like this, I can decide that n for my maximum, the number of times I've increased it, is twice, which means that I can answer B now. Its profit is going to be and you know what? I've actually answered these in reverse order. This is my answer for B, because this is my profit. My bad. This is my answer for A. So those are my 2 pieces to this puzzle. I needed to figure out what my price would be based on the round number, because I'm talking about for every increase in price. So that's got to be a whole number. Just like when we were dealing with trees, we had to increase it by a whole number as well. So that's kind of how that all shakes out. If you have any questions about these, make sure you ask. Otherwise, do the practice questions and you are good to go for the last assessment of this unit. Super exciting!